So I'm sorry that I can't be with you today. For I think certainly I certainly would have liked to, but unfortunately circumstances beyond my control have prevented that. So I will have two presentations to give you, and fortunately PowerPoint does provide us with the opportunity for me to record my comments. The first is this evidence of autoimmunity in Birdshot Retinochoroidopathy, and as you can see this was a joint effort by several individuals in the laboratory. And so let me begin with some concepts dealing with autoimmunity. So you can see here a definition from the web, from MedicineNet, and this is autoimmunity is defined, and I think this is a good definition, as a misdirected immune response that occurs when the immune system goes awry and attacks the body itself. So it turns out that autoimmunity per se, as opposed to autoimmune disease, is probably present in everyone and usually is harmless. However, once autoimmunity switches over to autoimmune disease, it of course can cause a broad range of diseases, and I'll show those some of them to you in a moment. We do know that the concepts of autoimmunity arise from cells, usually T cells, that are during ontogeny, during the development of our immune system, are removed from the circulation at two levels. One centrally, usually at the level of the thymus, and secondly peripherally, or peripheral tolerance, which is induced. However, some of these cells are thought to be released for a number of reasons, and they do show up in the periphery of, that is, in the blood of in our blood, and we can find evidence of autoimmunity, perhaps a little more common in women, but in the majority of cases really causes no problem. Now generally autoimmunity is evidenced by the presence of autoantibodies or by T cells that are reactive with host antigens, and that means that these T cells, important players in the immune system, are directed against parts of our own body. Now this is a list of autoimmune and autoimmune related diseases. You can see it's quite large, and the majority of these are thought certainly to be non-infectious, though they can be initially begun as an infectious process, and that becomes important in explaining some of these. But what I've done is that I've put in red disorders that are considered to be autoimmune or autoimmune related diseases, and that affect the eye, and includes ankylosing spondylitis and Behçet's disease, Crohn's disease, as well as Morin's ulcer, which is a change in the front of the eye, sarcoidosis, and uveitis in general. Birdshot hasn't made this list, but certainly would fit in the uveitis category. Now, this is a photograph and a fluorescein angiogram of a patient who has sort of many of the typical findings that we see in Birdshot. And the question really is, what is the evidence for possible autoimmunity in a patient who has Birdshot? Well, there are several, and the ones that I just want to emphasize today include cytokine profiling, changes in the kinds of products that are produced by the immune system that are thought to be pro-inflammatory, antigen recognition by the immune system, and if you remember, that's one of the key elements of the definition of autoimmunity. The HLA association, which turns out to be one of the strongest and most forceful, and also one of the most reproducible in all of medicine. And finally, the few cases of histology that we have of eyes certainly are suggestive of models that we know that are induced by these uveatogenic antigens. And so these are the ones that I'm going to emphasize. Now I'd like to begin with the question of human T cell subsets, and it becomes rather important for this discussion. To date, there are four major subsets of T cells that we're aware of, at least the subcategory that are called CD4 positive cells. These are cells that are involved in transmitting the immune response and carrying immune memory. They are critical in almost every aspect of the immune response. They're critical in interacting with other cells, including dendritic cells, which are cells that will transmit antigen to them, and with that an immune memory is obtained. The first cell that we knew about that can cause inflammatory processes is so-called Th1 cell. All of them we know are initiated by very different transcription factors and other factors that are found in the cell. We know that Th1 produces certain cytokines that are in the main pro-inflammatory. We also know that that's involved in some aspects of autoimmunity, and they're very pro-inflammatory. The Th2 type of cell is involved not only in parasitic infestations, but also is involved in transmitting information to B cells. B cells are ultimately the cells that will develop antibodies, so that there is this keen interaction between all parts of the immune system. The fourth one at the very bottom is a T regulatory cell, which we believe is involved in tolerance and minimizing autoimmunity, this is thought to have been either lost or degraded in some way in patients who have autoimmunity. The third one, between the Th2 and the T regulatory cells, the Th17 cell, these are involved in autoimmunity as well. This is the most recently found cell that produces, as you can see, a very different kind of repertoire of cytokines that are produced and are thought all to be pro-inflammatory. We also know that there are several cytokines that are needed to develop and put forward many of these cells. And so the Th17 part of this story is the one that, at least for the moment, I would like to emphasize. Now, why are we so worried about these products of all of these pro-inflammatory cells, including the Th1 and Th17? Well, two of these have been known to be associated with severe inflammatory disease. First one is IL-17, interleukin-17, by which the name Th17 comes. And we know that it's involved in the destruction of the areas between the cells, and also is involved in new blood vessel production or neovascularization. It's also been linked to neurodegenerative diseases such as multiple sclerosis and Alzheimer's disease. IL-22 is a product as well, and interestingly enough does not have an effect on the T cell, but has an effect on end organs, and that is organs to which this material finds itself, and we know it's very toxic to the retinal pigment epithelium. And it's expressed in many chronic inflammatory conditions, including psoriasis and rheumatoid arthritis. Well, a recent publication by our host, Dr. Foster and group, showed the presence of interleukin-21 and 23, as well as transforming growth factor in patients who had Birdshot who were not treated. And in fact, what they concluded was that the Birdshot patients with active disease, naive to systemic therapy, had elevated levels of these three key immune mediators, which we know promote T helper cell or Th17 cell in autoimmune disease. And so this already is highly suggestive of an autoimmune process and is not a normal finding. Now, the second part of this is the HLA structure, and many of you have heard the HLA associations. These are all the important major ones are found on chromosome 6. They essentially form a groove, and you can see this in the middle two cartoons, form a groove for antigens, and it's this combination that is ultimately presented to the T cell for collection of information and immune memory. There are several HLA associations that have been made with autoimmune diseases. You can see some of them, and I just want to call your attention to the relative risk. The highest one here being about 14 or 15, meaning that if you have this particular antigen, at least in a specific ethnic group, you have a 14 or 15 times higher possibility of developing the disease if you have this HLA. And you can see acute anterior uveitis as part of this. But keep that 14 and 15 in mind just for a moment. How HLA works is not completely clear. There have been two major thoughts, but in fact there have been several, but the two major thoughts that I want to put forward is one of molecular mimicry, which occurs when these potential antigens from microbes are sufficiently similar to self-antigens, and so they activate these autoreactive T cells. And you can see here on this slide a list of potential villains in the story of viruses that have been associated with a variety of autoimmune diseases, as well as cancers, suggesting that maybe there is this molecular mimicry that induces this response. A second idea is that the conversion of these class 1 molecules, particularly the one that's associated with Birdshot, form their own peptides, and they're presented by class 2 molecules, another type of HLA, to the immune system, which then mount then an immune response to this presented antigen, and no one really knows the reason. However, we see two things that are important in this discussion. The one on the left deals with a response of Birdshot patients' immune cells to an antigen, and I will come back to this in a moment. But also on the right is the HLA association, and this was the one that we did many, many years ago, and this has been corroborated, and that this gave a relative risk of almost 50. Now remember 14 and 15 being important. Well, 50 is almost off the chart. There's only one other disease that comes even close to this, and there have been reports from the Benelux countries suggesting even a higher association. Well, one can see then in Birdshot inflammatory processes at the level of the retina and the choroid. I'll show you photographs in a moment. The question is, what's the stimulating antigen? And in fact, that's what that previous photograph really showed. And so what I would like to show you, in fact, is I think an important part of this story, and it has to do with retinal S antigen. This is part of the back of the eye. It's found in the photoreceptors of human retinas, and this has been very well characterized. We also know that in animal work, if you immunize a mouse or a rat or a guinea pig or a monkey, you can develop a disease which looks, as you can see here on this screen, very similar to the kind of inflammatory diseases that we see in patients. This is a cross-section of an inflammatory response in an animal. And you can see the destruction of the photoreceptor layer, which is the part from which the S antigen is found, and also an infiltration of cells in the choroid underneath the retina, something that will be mimicked, I think you'll see in a moment. So this is one of the first histopathologic specimens that we were able to obtain in a patient who had long-standing inflammatory disease secondary to Birdshot. And you can see while the retina is very diseased, that there are the same kind of cells which are circulating through the retina. These are the dark areas, as well as through the choroid, very suggestive of what we see in the uveitis model. More recently, there was a publication by Dr. Polito in a patient who had Birdshot and also had a melanoma, so the eye needed to be removed. And a very similar finding was seen with cells in the choroid which were trying to probably get into this area. You can see the disruption of the retina, the destruction of the photoreceptors, all of these exactly what we see in the uveitis model. So the evidence, I think, is very strong to suggest that based on the HLA association, based on the responsiveness to antigens that we know can induce an inflammatory response, and based also on the histopathology, that there really is strong evidence to suggest that that Birdshot retinochoroidopathy is, in fact, an autoimmune disease. What initiated it still remains to be seen, but it certainly fits into the category of autoimmune disease. Thank you very much.